Hello student, most welcome to Dr. Acharya Academy. Today I'll discuss on the KÖSSEL-LEWIS approach to chemical bonding. This topic has been taken from the NCERT Chemistry Class 11 books. This is the unit number 4. Today's class number is 66. First, we'll know the background. In the year 1916, KÖSSEL and Lewis independently succeed giving a satisfactory explanation for the formation of chemical bonds in terms of electrons. They provide some logical explanation for this valence, which is based on the inertness of noble gas. We know that noble gas atoms has 8 electrons, and to form the inertness, because this electronic configuration is very stable. Lewis said that the nucleus and the inner electrons, it will be like kernels, and it has the outer shell which can accommodate a maximum of 8 electrons. So these 8 electrons will stay at the corner of the kernels. Sodium, we know that outer shell, it has only 1 electron. So he considered it is like a cube. Cube has 8 corners, and 1 corner for sodium atom, 1 corner is occupied by single electrons. But for noble gas has 8 electrons, as for example neon argon. Then all 8 corners of the cube will be occupied these 8 electrons. And these 8 electrons, it is called the octet of electrons, and it particularly shows the stable electronic arrangement which noble gas atom already has to make this atom stable. So Lewis postulated that atoms achieve stable octet when they are linked by chemical bonds. As for example, sodium and chlorine. For sodium, you know 1 electron, it is outside shell, and this electron will be transferred to the chlorine, because chlorine has 1, 2, 3, 4, 5, 6, 7. This 7 electron in its outer shell of chlorine atom. So this electron from sodium will be transferred to the outer shell of the chlorine atom to form this compound. And for this case, you can see that for sodium Na plus cation, it also has octet electrons. That means 8 electrons outside its shell, 1, 2, 3, 4, 5, 6, 7, 8. And for chlorine anion, Cl minus anion, it also, by accepting 1 electron, it also get octet formation. That means 8 electrons in its outer shell, 1, 2, 3, 4, 5, 6, 7, 8. And this part, it means this is the nucleus and inner shell electrons. Here also you see this is the nucleus and this is the inner shell electrons. This form the kernel as per the Lewis. And other molecules, especially for the diatomic molecule, that means chlorine molecule, Cl2, hydrogen molecule, fluorine molecule. So here right side you see the figure. Will explain these chlorine molecules. This dot structure actually it comes from the Lewis configuration. We'll discuss in this class later. So here you see that both chlorine atom has the 7 electrons. 1, 2, 3, 4, 5, 6, 7. And this chlorine atom, right side chlorine atom also has 1, 2, 3, 4, 5, 6, 7. So 1 electrons from each chlorine atom will form one pair of electron, which will be shared by both chlorine atom to form the octet for each chlorine atom. Here also you see, if you see this round, then 1, 2, 3, 4, 5, 6, 7, 8, and right side chlorine atom also it forms same way 8 electrons. So in this way, during the formation of the bond, it will form the octet of electrons. And octet is the stable octet. So now we'll discuss that dot, that means Lewis symbol. And Lewis symbol, you see that in this formation of molecule, only the outer shell electrons take part in the chemical combination. I already explained now, and they are known as the valence electron. That means sodium, 1 electron is there outside shell, so it has 1 valence electron. It is like that. So inner shell electrons are well protected and are not generally involved in this chemical bonding process. And Lewis introduced simple notation to represent valence electrons in an atom, and these notations are called Lewis symbols. So Lewis symbols are like that because for lithium, if you consider example for lithium, it has the 1 electron in the outer shell, so 1 dot for lithium, and beryllium 2 electrons in the outside shell, so 2 dot. And these all are valence electrons. And in this second period, this is the second period's elements, and extreme right side is the neon, the noble gas atoms, which has the octet formation because 8 of the electrons in dot form it is there as per the Lewis symbol. Significance of Lewis symbol: the number of dots around the symbol represents the number of valence electron. This number of valence electrons helps to calculate the common or group valence of the element. The group valence of the element is generally either equal to the number of dots in Lewis symbols or 8 minus the number of dots or valence electron. For sodium, so it has 7 electrons, so it will form 1 valence electron because 8 minus 7 is equal to 1. So 1 bond chlorine atom which will form during the combination of chemical bonding. KÖSSEL drew attention to the following facts. In his view, he explained in the periodic table the highly electronegative halogens and the highly electropositive metal ions are separated by the noble gas. You see the group 17 is the group 17 is the halogen highly electronegative, and this is the group 1 alkali metals, lithium, sodium, and this group 17 and group 1 is separated by the group 18. Group 18 contains the noble gas. So the formation of a negative ion from a halogen atom and a positive ion from an alkali metal atom is associated with the gain and loss of an electron by the respective atoms. That means whatever Lewis suggested for KÖSSEL, independently he also suggested the same thing, that alkali metals so will lose the electron and halogen atoms will gain the electrons to form bond. And the negative and positive ions thus form to attain stable noble gas electronic configuration. The noble gas have a particularly stable outer shell configuration of 8, that means octet electrons, which configure NS2 NP6 like Lewis. Same conclusion about the bonding formation, but it has some difference that will tell now that KÖSSEL particularly told this formation of bonds, that means by negative and positive ions is stabilized by electrostatic attraction, because positive ion and negative ion, this attraction, electrostatic attraction will stabilize them. Example for this case also, if you consider the sodium chloride, because sodium chloride is very common example. So for sodium electron structure, you see the outer shell configuration is 3s1 and it will get the neon octet structure by releasing one electron to form the sodium cation. And chlorine, its outer shell configuration 3s2 3p5, and after getting one electron from sodium to get the stable argon structure, argon octet formation, stable structure by forming the Cl-, that means chlorine anion. Similarly, the formation of CaF2, in that case, 2 numbers of fluorine atoms. So calcium, its outer shell configuration is 4s2, that means 2 number of electrons is there. So by releasing these 2 electrons to get argon electronic configuration, it will form Ca2 plus cation and will release 2 electrons. These 2 electrons will be accepted by 2 numbers of fluorine atoms. That means each fluorine will take 1 electron to get fluorine anionic structure, and this electronic configuration for fluid anion is like neon's electronic configuration. So finally Ca2 plus 2F minus, it will form CaF2. So this bond, whatever this bond formed as per the KÖSSEL, especially mentioned that this bond is as a result of the electrostatic attraction between the positive and negative ions, and he termed is as the electrovalent bond. That is one difference from the Lewis approach, because he specially mentioned this bond is electrovalent bond because this bond is formed due to the electronic attraction between cations and anions. The electrovalence is thus equal to the number of unit charges on the ion. The calcium is assigned a positive electrovalence of 2, that's why we written Ca2 plus, and while the chlorine a negative electrovalence of 1, it will be written as the Cl minus, Cl superscript minus symbol. It is 1 electron, that's why only minus. If in other case, if you put the electrovalence negative electrovalence 2, in that case you can write minus 2. That's the difference. Now oxygen atom, we will write O superscript minus 2. So KÖSSEL now his postulation is valid and it provides the basis for the modern concepts regarding ion formation. Till now it is valid in our chemistry by the electron transfer and the formation of ionic crystalline compounds. His views is very important for understanding and systematic understanding of the ionic compounds. For ionic compounds, till now, this KÖSSEL's view is valid, and at the same time, he also knows that most of the compounds, these views will not work, because nowadays we know that in addition to ionic compounds, also covalent compounds, non-covalent compounds, that means covalent bonding, non-covalent bonding also exist. He knows in that time that his views may be limited to some number of compounds which forms from ions by electron transfer. I hope that you understand this theory, and next class also will take this concept to go in details. I have the podcast in the same name, Dr. Acharya Academy, for honors degree chemistry level education. You can go through this to get higher knowledge about this. Thank you so much for watching this.